welcome. This is SCADA training with Simon. We're going to go over UltimateAccess today, some tech notes. My name is Christian, and I'm part of the technical support team here. And we're going to help you reduce your learning curve and increase your overall effectiveness with the software itself. So if you would be courteous to everyone and mute yourselves so I can educate everyone. And then at the end of the presentation, there will be a link to our email and our phone number in case you need some customer service or help with the products. And with that, let's begin. Okay, so like I said, we're going to go over the SCADA today, UltimateAccess, the tech notes. Where does SCADA fit in your network? So if you're using PLCs and you're using HMI, XPanel, or PLC, there's a lot of data that you're gathering from the factory line or whatever you're automating. And then you want to see that at the palm of your hand or ease of access. You're gonna want SCADA, or in our case, UltimateAccess, and it delivers amazing communication with the XPanel or PLC. You can communicate via serial, Ethernet, or whatever communication you're going to be using. So that is just a little overview of how CIMON SCADA it can be implemented into your system. So we're going to go over the basic features today. So the foundation of any project, you're going to need a database, so all the tags and whatnot. Then a little cool feature that is with CIMON that a lot of other people have is our scripting feature, which is a shining candidate. And then we're going to go over a trend, data logging, some alarms, reporting feature, and then last but not least, security, and then some other miscellaneous objects. But these are the basic features we're going to be covering today. All right, so first and foremost, the database, the basic structure for any program that you're ever going to create. So for today, we're just going to be messing around with the PLC simulator for ease of access. And then this is the kind of the program we're going to do today. We're going to do a stepping program where certain tag values increase by 5, 10, 15, up to a value of max 200, as you can see right here. It'll be going up to a max of 200, and then after it hits that, we're going to want it to come back down to 0 and then just loop it up and down from 0 to 200. Sounds easy, but can be pretty difficult. For the third tag, we're going to generate a random value between the min and the max. So a random value between 0 and 200. And then tag 4, we're going to want to toggle between 0 and 1, and then generate a random value between 0 and 1 for tag 5. These will not have any max and mins because they're digital values, unlike the analog values that we just mentioned above. Okay, and then notice how we've given numbers to these tags. We're indexing these numbers. So if you were to index something with 2, tag 2 and size 2 become attached to each other. They become useful to each other because they have the notation of 2 after the string. Okay, so where to find the database? After you've downloaded UltimateAccess, which I will show you, you're going to see the database up here. So I've shown you where the database is, but let's go through the basics real quick. I'm going to show you how to download it, show you how to start a new program, and then I'm going to show you how to get to the database. I'm going to close this. Okay, so when you open up CIMON-D, this is what you'll see. You'll see a basic canvas with nothing on it yet. You want to start working on stuff. So new project, demo purposes, okay. So then we get this, it generates a page for us. We're going to save that page. And then it's named page 1 in demo purposes of our folder. So you have to state, you have to name each page you want to start working on. So now we've created a project, we have a page to work on. Now the database is right here. So you click on this, and then this brings up this little interface, and we can start generating tags in here. So let's go back to the presentation and see how we're going to start generating these tags. So we went over how to navigate to the database. It's this little tag symbol right here. And then we want to create this cool little library of tags. Like we have so many groups over here, and then we have digital, analog tags, all these group tags. So we're going to click this button up here, which allows us to generate all these tags we want to. And it's going to kind of look like this. It's going to be an edit tag window, and we want it And just for notation purposes, this is a reminder of what we want to set everything to. So I'm going to go through each one, and then we're going to come back and circle back to this slide. So today I wanted to create a folder for input. So a folder would be a group: digital, 1 zeros, analog, any values, and then string text. So I want to create an input folder, so I do that. Click on input. I can make a tag within it. So tag 0, make that an analog. We're going to make it virtual for our sake because we're not going to be communicating with any devices technically. That's okay. So we have a tag 0. I want to create maybe tag 4, which is a digital value. And click on it, and then press OK, and then we get a digital value. So we also have an analog and we have a digital, and then last but not least, I can make some string value. Let's do username. So inputs, or the data that's used for this, would be text, since it's a string value. So now I have 3 tags. I have a folder. Should be good to go in terms of making a project. And we're going to have to, of course, have a lot more tags than this. But this is the basic foundation: how to create a group, how to create an analog, a digital, and a string tag. All the 4 basic foundations of creating a tag. So I'm going to close this project and open up my project that's already complete. Okay, go back to the main view. So this is essentially what we're going to have the screen look like, but we're going to go back into the tag database. So as you can see, I have a lot of groups over here. I have input, I have login, step, and range. We went over these 3 right here. So input, I have my 6 tags, 0 through 5, analog for the first 4, digital for the last 2. And then I put some initial values. So if you go to the tag itself and you go to advanced, you can change the initial value to whatever you want. I mean, we can have it start at 0 if we want. It doesn't necessarily matter, but this is the value that will start when the program is started. So essentially it can be like term deemed retention, but you're creating the retained information. So then over here we have a description. So we can write whatever we want, so we can remind ourselves and help troubleshooting in the future. So for this description, I'm doing a stepping input of step size 0. So it's going to be increased. Step size 0 was 5, and it's going to be increasing to max and min up and down by 5, increments of 5. And then it'll do that repeatedly. Same thing for tag 1. It's going to go up and down by 10. And then tag 2 is going to go up and down by 15. Random value between min and max. And then we're going to have tag 4 and tag 5 be digital inputs, toggling and random. So for the range or the stepping size, I want to make them, say you want to deal with int 8, so just 8 bits. You can click on this, go to advanced. You can change the data type here to be assigned int, so you can have the negative included, so negative 128 to 127, or you can go unassigned 8, which will just make it only the positive range, so you're unassigning the operator. And then we have BCD, UBCD, and then float. So float would be used for decimals, like real, in terms of Allen Bradley and Siemens. Anyway, so data type, we covered that. Now going over to range, we're just setting parameters for our program. It'll just yank these values from the tag database and then use them throughout the whole script. So then the min will be analog, and then we choose the initial value to be 0 and 16. This part doesn't really necessarily matter, but the min we've set the initial value to be 0, and then the same thing with max, we've set the initial value to be 200. So this will make sure that we have a max of 200 and a min of 200. Another way of implementing this would be to go here. You can choose to have a min and max value for said tag. So I did the PLC, but 0 to 200. You could also do 200 right here. And then this tag could never go out of the range of 0 to 200. Right, let's go back to the presentation. So we have made our 6 tags, the other 3 tags for stepping size, and the other 2 for our parameters. And we set all of our ranges to this. Next up, we're going to go over the script that talks about the stepping size. So we're going to do a simulation visual basic script. So if and you don't have to be a master of this either, because in our help file, we have plenty of examples to show you how to actually do the coding. So we can kind of guide you to using script, even if you've never even touched it before. So let's take a look at the script. You might not be able to produce something like this, but at least we've given you an example where you could potentially branch off from this, or you can use the help file for other examples. So with this script, we're declaring our min and max. So we're going to, the min value and the max value will be those tags that we set, 0 and the 200. We're going to have a string which is going to become the tag, and then we have a stepping size which is going to do our up and down feature. It's going to be ++5 or -5. And then we're going to start declaring our indexes. This is what I was talking to you before. The tags that have numbers at them are called indexes. So from 0 to 5. Now in this script, if the index was less than 3, so tag 0, 1, 2, those are going to step up to 200 and then step down to 200. That's what this script is declaring. Now, if the index is 3 itself, just randomize the digit. We've already talked about that. If the index is 4, toggle between 0 and 1. And if it's none of the above, if it's not 0 through 4, meaning 5, it'll be a random integer between 0 and 1, so 0 or 1. And then at the end right here, we have this cool little sleep function. In case your program's too quick or you're trying to generate too much data, you can slow it down by putting a sleep function in there. So sleep for 1 second, then it'll rinse and repeat right through the program itself. Okay. Scripts. I have some other script features that I wanted to show you guys before we get started. So a little basic one that I did myself. So I just named it demo2. So I declared a delta. So I declared a constant. So when tag 0 is equal to input tag 0. So we're just declaring our variables at this point. So if delta, our stored variable or constant, and the variable, then if it's equal to 100, then it will inverse, and then it'll start subtracting 10 from the tag value. And then if delta is -10 and tag 0 is 0, then it will flip it back to positive, and it'll just keep going up and down to 100. And then this little sleep function right here, it sleeps for 200 milliseconds. Whatever number you put in the sleep function is milliseconds. That's why 1,000 was 1 second in the last script. Okay. So just to see what the script kind of looks like all together, let's run it. So to run a program, you click this little inverse sign up here. It looks like a crossing symbol. So that will run the program in the back. Ignore a lot of the other stuff because we haven't gone over it yet, but just pay attention to these numbers right here. As I turn it on from each one, okay, I can't touch that one. This will be talked about later. This is a security feature. But this button right here is the one we're mainly talking about. So tag 0 is increasing by 5. Tag 1 is increasing by 10. This one's increasing by 15. And then this is randomized between 0 and 200. And this is toggling between 0 and 1. And this is random. You may not see random because it looks like it's toggling, but every tick, sometimes it is the same variable. And as you can see down here, it is different. The black line is toggling between 0 and 1. The red line is sometimes staying 1, 2 ticks, or 3 ticks, or so forth. Ignore that prompt, that's later. So going through, now we're going to talk about the main view. I want to display the tag value. Prompting this all the time. I want to display the tag value, the name, and I want to display the description of the dynamic tag. So I want to know what it's called, what it's used for, and what is the value of it. And you can do all of that with simply the tag name itself. So if you click on the tag itself, you'll see some tag variables to the right of it. You'll see description, you'll see name, and value. By default, it will always be on value, but you can choose to show the name or the description if you want. So you don't have to write it out, or if you ever change the description, it will just change by itself. It's a lot easier when you use the functionality of the tag, like the description, or you can use any of these other tag variables that are associated with that tag. So this is what the tag name will look like when you use the name and description. It will be the tag itself, input.tag0, the name, description. Not the name of the tag, but name declaring that it should use object 1 in the tag name, or it should use the name of tag 0, but the name of this object is object 1. Anyway, moving on to the description, the same thing. When it declares that it used a description, it will show the description of the tag and the variable. We're going to go over that real quick. And then we're going to create a button to start and stop the simulation. So I don't know if you guys caught in the script, I didn't go over it, but it says while switch is equal to something. So let's go over that real quick. We go to the simulation. It says while get tag value of switch. So if it's while 1, meaning on, if the switch is 1, then this whole script will run. If it's 0, none of this will run. So just creating a switch value. And that switch is right here. So I have created a command that it's going to bit toggle switch on going from 0 to 1. So the way to do that is just, you're going to pick the tag name switch, which is a digital value that I created in the tag database. It's right here, the digital tag. And then I want to choose it to toggle, and then it'll set the lamp when it's done, and then OK. And then this will toggle this lamp to turn off and on. To show you in the tag database where I did that, go to demo basic, switch, create a tag name switch, digital, 0, 1, and so forth, and then you have your little switch feature. So you saw me press this button, it turned off and on the numbers adding and then randomizing and toggling. It turned off and on the script. So just showing you what these question marks mean. So first, this is just the tag itself. Input.tag0, that's going to be the value. This right here is going to be the name of the tag. And then right here is going to be the description of the tag. So the way to do that is to go to draw, tag value, click anywhere, choose the tag name. So I want to look at tag 4 maybe. I want the description of tag 4 right there. So this right here will show the description of tag 4. But I'm not going to use that right now because we already have a set in stone functionality. Going back to the presentation, we've done the button for switch, and we've done description and tag name. And then this is what our main view is going to look like. We're going to have a button, some values, and then descriptions. I want to be able to run the program. So to be able to do that, you have to set the starting page. The program will not set the starting page by default for you. So the way to do that is to go to CIMON configuration. So I'm going to show you that real quick. It's this little button up here. Now, by default, it's going to be none. And it will not run for you unless this is, it won't even tell you that there's an issue. It just won't run. So you have to go to starting page, and then you're going to pick main view. Well, for us, we're picking main view. You pick whichever page you want to be the first one. So then press OK, and then as I start it, the front page will be the one that we were declaring. And then this button will change these values based on the script. This is the tag name, input tag dot index, whatever. And then we have descriptions over here. So these were the descriptions that I put inside of each tag to basically declare what the variable should be doing and to kind of educate the user, whoever's utilizing the SCADA in the first place. Okay. All right, back to the presentation. So we have declared on how to start with starting pages. We went through the tag values. We kind of went through script. So basically now we're going to move on to how do we look at historical data. We want to look at the trend. We want to know what our data was in the back time. We don't want to just know the real-time value because that doesn't really show us what's going on. That just shows us that something is currently happening. But I want to see what happened 4 hours ago. Why can't I see that? Well, you can do that via a trend. So we're going to create a Y by time axis. So the Y axis will be the values, and then the X axis will be your time. So that's what it means by YT, Y axis, time axis. And then multiple trends. So if I want to see them separate from each other in one little trend graph, then I can do that as well by selecting multiple down here. The way to get to this trend is to press the draw button, go all the way down to trend, click trend, and then this configuration shows up. So you can pick YT or multiple. For our selection, we did YT first. And then you're going to press next, and then you can start configuring what you want to be on the graph itself. So for the tags that I want to show, I did input tag 01 through 3. another graph will have tag 4 and tag 5 for digital values, as you have already seen. And then this is what the graphs look like as I've shown you. So as you customize it, you can tell it to show the tag names and tag nicknames, or you don't have to. You don't have to show the times. I'm just showing you the complete functionality of the graph, and plus this is just basics. So on the left, you'll see all of the tag values together, and on the right, you see them spread apart multiple. So this is what a multiple would be, and then this is what it all is conglomerate. All right, so let's go look at that real quick. So this is the tag values. Down here, you see I have added a toolbar. So if you double click on the graph, you can look through all the customizations. You can change the colors. You can change the colors of everything. I can change this to white. I can change this to black. I can basically do whatever I want with this graph. And then I can input, or I can put all the values I want to look at. So you see my little key down here that shows you what I'm looking at. And I can choose the colors of the lines I want them to be. I can choose to show the toolbar or not to show the toolbar. It'll go away immediately. Right, double click, come on. And then go back to the toolbar, press the toolbar, and I can show it again. So these little features show me that I can stop the historical data whenever I want. I can print the results. I can zoom in or zoom out on the results, and I can choose which I want to, what times I want to look at. So if I run this real quick, and I start this, I can start looking at historical data, but lines are going to disappear if there's no data logging going on. So this is real time, and once you press pause, the values kind of disappear. So we have tag 1 that's being data logged, so I can go back in time and look at that if I want. I can change what time I'm looking at, what hour of the day, and then the range of the time I want to look at. And then I can move forward or backward based on wherever I see fits. And then if I resume the photo, all the other numbers will show up. Now, if you include these tags in data logging, they won't disappear when you press the pause button on the graph. Only the data logging values will show up when you press pause. And then I did the same thing for digital over here as well. All right, so speaking of data logging, I want to start logging tags. So I wanted to see a report of what these tags are looking like throughout the whole day. So you can click this little button up here and it'll show you the interface for tag 1 logging. And you have to declare a model before you can declare a tag to start logging to that model. So it's just the way it works. You have to declare the model before you can declare the tag. So in here, I wanted to name it tag 1 logging model. And it's going to do it at a regular interval of 1 second. So every 1 second, it's going to log the data value of tag 1. And it's going to save it in this tag file. I decided to save it to the project file itself, which was called demo basics. And then it will stop saving to that file once it hits 1 kilobyte of data. When it hits 1 kilobyte of data, it starts going on to the next file. And then it will max at 10 files, thus overwriting the last or the first created file. So you can change this up to 999 if you want. You can do it monthly and then have it 999. So you can do it 999 months in a row. That's the max. You can put 1,000 in there, but then it prompts you to put it down to 999. So between that range. And then you can have it overwrite. You can have it warn you before you overwrite, or you can have it overwrite after keeping. So you keep the old file and then you overwrite. So that's how you get around the whole max number of files. And then after you've created the tag 1 logging model, you need to choose what tags you want to log to that model. So you go to the edit tag feature and then click on the tag you want to model, go to advanced, then there's this data logging feature down here, click on that, and then you have to select the model that you just made. So we just made tag 1 logging model, so I'm going to click the drop down and then select it, and then it will start logging this data to this model. And then whenever I want to see that data, it generates a CLD file, which can be then converted to a text file, to a CSV for Excel, or a clipboard, just copy and paste. So I'm going to go through each one of those real quick. And one more thing. So look, pay attention to this command up here. It's log file dialog parentheses open parentheses close. This command lets you look at the data logging models. So you require some form of a button to press to start generating these reports. They're already generated internally, but to get them yourself, you would have to press a button. I have made a button called View Data, and it's just a simple push button. So if I go to Draw, then I press Button, that's how I got this. It's a button config, so I named it View Data, and then I gave it a command to do. So command expression, and then I just write the command that I put in here, which is log file dialog parentheses open parentheses close. So whenever this button is pressed, it will generate that reported data for us. So let's go ahead, press this, and start looking at the functionality. So I'm going to start up the numbers, let them go for a little bit, press View Data, and it generates that prompt already. So it's been tracking. So whenever the SCADA is turned on, it will start tracking those numbers, as it should. So as you can see, I have some dates on here that I've been messing around since I've last shown this. So for today, we're just going to look at 416. I want to convert this to a text file. So it generates a text file for you to save in the folder that you chose, and then you can press OK. And so it saves this text file, or I can do a clipboard. So this is what was printed to the clipboard. It's all the dates and times. Every 1 second, it's recording the value of tag 1. Ignore this, that's data logging. Now, if I wanted to see the text file and the CSV file, then I would just go to the program file where it's located. So then demo basic. So there we go. It saves in a file itself. So tag 1 logging model is down here. It's a folder itself. So if I click in there, I get all these dates and times. So we just did this one, the 416. So it's down here. So if I click on that, it generates the same report that I just copy and pasted. Now, if I want to see the CSV, go back to the presentation, make a CSV out of it. And then I'm going to save that, and it'll save it to the tag 1 logging model as well. So then, as you can see, it generated right there, 416 CSV. And then it will generate an Excel sheet for you to look at with all the numbers, with all the times, every 1 second being tagged. No, I do not want to save. Let's get out of this. And then go back to the presentation. Okay, so we just went over data logging, how to convert the data from a CLD file into a CSV, TXT. It's pretty easy, right? So first we have to make the button. The button generates this dialog box down here. Choose the file that you're wanting to look at. You can convert it to a TXT file, clipboard it into your notepad, or you can CSV it into an Excel file. And then this is what I've shown you, and this is what it looks like. Now we're going to start looking at alarms. Now, in regards to data logging, we're able to record data. Now with alarms, we can also record data, but we need to set parameters for the alarms to go off. So how do we do that? So for the purposes of this presentation, we're just going to do 1 analog and 1 digital. For the analog, we're going to make a high alarm go off at 160, 120 for high, 80 for low, low, 40. And then I want my tag 0 to be that alarm. So there's a little checkbox down here, assign as alarm tag. So after you go to the edit tag box, you can assign it to be an alarm tag. Then this alarm tab shows up, and it disappears if this is unchecked. So it appears once you check it. You can go to that alarm tag, and then you can choose high to be 160. So let's go look at that real quick. Now if I uncheck this, alarm goes away. Alarm is no longer here, but if I assign it on the alarm tag, alarm pops back up. Now for high, we chose to be 160, high 120, low 80, low 40. I also want tag 4 to spit an alarm when it goes from off to on. So when it goes from 0 to 1, it's supposed to spit an alarm out. So let's look at tag 4. Oops, wrong one. Tag 5 is the one I wanted. Never mind, my bad. I'm sorry. So for tag 5, I'm going to assign the alarm tag value. I can do it for tag 4 as well. But for tag 5, assign the alarm value for a digital value. Go to alarm tag. And then whenever it goes from off to on, so from 0 to 1, the alarm will go off. And I can do the same thing for tag 4 if I wanted to. Press assign alarm tag, go to alarm, and then off to on. And then press OK. But I'm not going to enable it. I don't want all these alarms going off at once. So that's that alarm. So this is the digital side that we saw. So off and on. That's how you choose for digital. There's so many options. You can do on and off to on, whenever it toggles back and forth, or if it's set on for too long, or if it's set on off for too long. Okay. To draw the alarm summary, you're going to press draw button, go down to alarm summary, click on anywhere on the page, and then you'll get this prompt to show up. You can tell what alarm levels to show, and then you can start customizing by pressing the next button. And then this is the alarm window that technically shows up when you have created your alarms. So if I personally, since the page was getting too filled, I created another page called alarms. So to do that, you press new page, and then it generates this page 7 for me. So by default, it names it the next page in line. But I can save that page as whatever I want. So I can save it as new page. New page. And then it changes the name to new page, and now it's part of the project. But I don't want this part of the project, so we're just going to get rid of that. So I created my own page called alarms, and then I created this this alarm window right here. So remember, we went draw, we went alarm summary, clicked anywhere on the page, and then we can start generating what alarm levels we want and customize the whole alarm schedule in general. So next, we can do alarm zones, which alarms to show in general. I don't have to show my digital alarms if I don't want to. I can just show the analog alarms, but I'm showing all alarms for this example. And then you can do alarm status. You can tell the alarms to either accept alarm off, on, change, or acknowledge. And then we can declare what categories we want to show. So I'm showing time, tag name, tag value, and alarm status. That's all I want to show. I can show all these other ones if I want, alarm count, alarm time, alarm on time, and so forth. You can really customize it. And then this is where you would choose how to show your time. So you can show time from any of these declared features up here. But for us, we're just going to do year, month, day, and then hour, second, or hour, minute, second. Next, we're going to do, these are the colors. You can choose these colors to be anything you want. So this is the color when the alarm's off. This is the color when the alarm's on. When you acknowledge an alarm, it will turn blue. And then if an alarm stays on for too long, it will be yellow. We can choose to name the alarm, whatever we want. And then this is for printing. You can choose there to be a page number, date, time, and you can center it left or put it to the right of the page. And the same thing goes for the footer. Not too much customization, but enough for you to use. And then if you ever want to change your alarm, you can go back in and look at the different things that you were looking at and change whatever needs to be changed. So let's go look at what alarm looks like. So after I press this button, this alarm goes off when it triggers from 0 to 1, and then the other alarm triggers at, was it 40 or 20, 60, or no, 40, 80, 120, 160. So if we go to alarms, it'll start showing the alarm results. So tag 5 going from 0 to 1, the alarm's going on. Tag 0, the alarm went on because it reached over 160, and once it goes back down below 160, it's going to be a variation. And then once it hits below 120, it'll be off. So I don't want to save that. Now, if I go here and I acknowledge, it'll become blue. I've acknowledged this alarm, so now it's blue. Same thing here. And it's probably going to be too quick. But I acknowledge the alarm, it turns blue, it goes away. Okay, so that's a little bit about alarm. Oh, last thing, sorry. Now I want to save the alarm. The alarm will save into a file, whatever you want to name it. But it already generates a save file for you if you choose it to be that manner. But right here, I'm just naming it whatever I want. So I'm going to do purposes, and then this makes a CSV file for us. The other one will be a text file that does it by itself. Okay, so we go into the folder. So demo purposes, we just made this, and this is the alarm that's being compiled as we talk. So if I click on this, we just save this. This will be the CSV file of everything that, and it doesn't show the historical data unless you show historical alarm. The CSV file will only show what you have shown up here. So since these were the values that were showing when I pressed it, those are the values that are going to be showing. Now if I do historical alarm and I do it this way, then I can press save and do the same thing. So demo purposes, save, overwrite here. Oops. One second, sorry. All right, here we go. So I created a different folder name or a different file name than the one I was using before, and that seemed to solve the problem. There might be another issue at work, but I'm just trying to get it solved for you guys quickly. So this shows the alarm summary in a CSV file for you. From every time an alarm is triggered or goes off, it will show it in this file for you. Alongside something you will not have to save on your own, this text file, we didn't do anything for this text file. This text file is saving on its own. So it will tell you what is going on with your alarms throughout the whole day whenever something is triggered or turned off or acknowledged in a text file. Nice for you. And it will keep compiling for you every second that the program is on. The way for that to be shown, the next step. So I want to see my alarm view. I want to see that text file, and without having to press anything, I want to do it on its own. So what you do is you press this little alarm button, and then it'll bring up this configuration. Click on File, Edit, and then we're going to choose where we want to save the text file to. And you can choose what you want to show in the text file. So I chose tag name, time, tag value, alarm status, and alarm type. And those were the 5 values that were showing up constantly in that alarm summary for the text file. And then this is exactly what it looked like when I showed you. Right? So that's a little bit about alarms, tag values, and trends. So let's move on to reports, the conglomerate part. Reporting is a nice little feature. We can choose to show as many tags as we want, and it really is based off of your customization. So it's really beneficial if you use a customized Excel sheet, and then you can just tell the SCADA to input the data into any cell you want. So say you did your own headers, you did your own logo and everything in the Excel sheet, you could tell it to be C3 to C7 as your cells to declare tag value or declare data values, and it will just post into that Excel part. So just to show you kind of what I'm talking about, after you click the report button here, you can make some models over here. So I'm going to create a model name of input out model, and it's going to record daily at 5:19. But on ours, I chose other, and I want it to be every second. So, or I wanted it to be, no, not every second. I wanted it to be at an output. So when the value of tag 0 reaches 200, it will save the current values of whatever tag 0 through tag 5 are at that exact moment. And then you have to register the tags you want to be read or written. So we're going to be writing data onto Excel sheet. So we have to click the register tag. We're going to be doing an Excel worksheet, and then see it's a custom form, so something that we've already developed before. CIMON or before the SCADA is able to actually save data onto that Excel sheet. This is something that we've already generated ourselves. So you're going to use write data to record, and then you're going to use read data to write data onto the actual SCADA itself from the Excel sheet. So you can write data onto the SCADA from the Excel sheet, and you can write data onto the Excel sheet from the SCADA. So you can read and write. So the option's right here. So for the one that I'm showing you, I want to write data onto the Excel sheet. So whenever something was triggered, B2 through B7 cells will be filled with data on these values. And then it will look something like this. This is the customized part. So this part will not show up and this part will not show up. Only B2 through B7 will show. So this is what's being written. This is customized. Everything outside in the columns and rows is customized. And then we can also read data, as I was saying. So we can take data from an Excel sheet that's already there and just write it into the SCADA program itself. So, and we can also do this every day. We can do it's basically a schedule, or we can do it when a certain output is triggered. So for us, when tag 0 equals 80, it will take the data that's stored in the Excel sheet and write it into the program, or write it into the tag values and overwrite whatever the program is doing at that moment in time. So that's the point of the reading part, and we've already went over the writing. So before we get into security, let's go look at what's going on. Okay, so all right, so when the output input tag 0 is equal to 200, this will read all of this or write all this data to the Excel sheet. The Excel sheet that I've made is actually called inputs. So you can see that some data is already in here. So 175.20. So I've already created this myself. B2 through B7 will be generated based on whatever is being thrown into it from the reports. So that's what you kept seeing too. The prompt when it said, do you want to save? Like it's trying to save into this file because the output of 200 was reached by tag 0. So let's just watch what happens inside CIMON, or beside the SCADA itself. So when this reaches 200, it's going to prompt me to save. It hasn't reached 200 yet, so I'm just going to speed it up for you real quick. So let's put it at 185. Once it hits 200, a little bit after, it's going to tell me, do I want to save data? I'm going to say yes, I want to save data into that file. I want to overwrite. So let's wait a second. So there we go. Here's the prompt. It's asking me, do I want to save data into that inputs Excel sheet? Say yes. And then once this hits 80, it's going to actually read the data from the Excel sheet and then input it into these numbers, bypassing whatever the algorithm tells it to do, or tells it to do right now. So the scripting is telling it to do go all the way down to 0. But as soon as it hits 80, it's going to generate back up to those data. So right there, it just jumped right back up. And the data values that are stored in there. Notice how the alarm text is still triggering. So these are the tag values that were saved when tag value 0 is equal to 200. And because it's being done every second, it didn't technically hit the values it should have, but it's updating pretty quickly. Okay, so last but not least, some of the more features we're going to go through. So we went over reporting, how to read and write data into an Excel sheet, and declaring the cells you want to read and write into. And then for security, we're going to create some users and logins, so with some basic access privileges. So 100 is your lowest security level. So it's your default level when you log into SCADA. 1 is your highest, and you can see here that I've made an ID. We didn't name it Sean, but we named it admin. But the ID is admin for the password. And that's going to give us a level 1 security clearance, and we're going to be able to access anything. I don't know if you remember me saying that there were some buttons I couldn't press earlier. Well, that's because the security was enabled, and we're going to bypass that soon. So to create some login information, we're going to have to create 2 tags, dynamic tags, both of them being string. So You're going to go into entry data. You're going to choose the tag name. I made login username, and you're declare it to be text. And the same thing for here. You want it to be declared text, and then we're going to name it login password. Careful right here. We want to name it a password. So we want to declare that it is a password by checking this box. And then we're going to, the title is username, and then the title for here is password. And then we're going to generate a script right here. So this is that one script that we were looking at that has login username and then login password, and then it executes the information that was inside those tags. So we're going to create a button that runs the script run login. So if I go to alarms, go to username, I type in admin. Let me show you something real quick before I do that. All right. So I can't click on this PLC button, and I can't go anywhere now that I've hit this alarm because there is a security clearance. As soon as I enter this password and log in, it will credential, or it'll use these credentials to log in. Now I have access to everything. So I can go to the PLC page if I want. I can go to alarms. I can go back to buttons. I can press this button that I was not able to press earlier, and it will only affect tag 0. It'll make it go up by 10 and then down by 10. And then this one will also step it up and down too. Okay, so going back to, so this is the login features. Now how do we get there? Go to tag database. I've made a username and login tag specifically for them. So if I go to login right here, my group folder, and I have a username and a password. So notice how I named it a string tag because we're entering text into here. Nothing else fancy was done over here. All I had to do was name it username and a string. So nothing else was done. So I just had to make 2 random. I could have named these anything I wanted to. And I didn't have to necessarily name them username and password, but it makes it better for clarification reasons. So if we go back to alarms, all I did was make a dynamic page for login and username. And I picked the tag name. I went to login, username, value. Okay, that's it. So I can enter data into here as well. So entry data, I'm entering data for this tag. And then the tag value shows whatever the username is. So you have to be able to, you have to display what's actually inside the tag, and then you have to enter what's inside the tag. So we could declare an initial value for the tag if we wanted to, and then it would show up here instead of question marks. And then we would enter the data into that and press the login. So for security purposes, we're here. So I named him admin. The name is admin. The password's admin as well. Same thing for basic. Basic are both the login and password for the basic privileges. But if you notice right here, when I click on PLC, there's a security tag up here. I made it security level 95. So if you're not 95 or higher, 95 to 1, I mean lower, 95. If you're not lower than 95 or 95, then you will not have access to this button. So by default, you're set to 100. And if you were the basic user, you wouldn't be able to use this either because your security level would be 99. So you're below, or you're above 95. So you have to be 95 or below. So highest privilege being 1. So that's a little bit about security. You can log in with a toolbar, and you can log out and change your password with the toolbar. I did not have the toolbar running because it looks nicer when the full screen is met. So if we go to here, and then I can show status bar and show toolbars, it will be able to show that login credential whenever I run the program. So up here, we have a login button and then log out and change password. So if I go admin, press OK. Now I'm logged in. I can press alarms, I can press PLC, like I've already logged in that way, but once I log out, I won't be able to press these buttons anymore. I can no longer press these buttons. So we're moving from that. We're gonna speed along here. Time is almost up. We got 8 minutes left. Come on. Okay. So then that's how you log in with security features, declaring who's going to be the highest privilege and who's the lowest privilege and whatnot. So let's talk about a little about page properties. You can tell the page where to run in the position. So as you can see here, I chose the page to run Y150. So it starts at the top left of the grid, and going down is positive and going right is positive. So unlike math, when we, going down is negative on the X and Y axis, going right is positive and going down is positive. So this is going to go right 0, and then it's going to go down 150. So the page is going to run 150 pixels below starting point of usual 0, 0. And then the width and the height of the page is going to be 1,000 by 85, 850. So then that's how you do the page properties. And then you can double click on the empty part of a page to bring up this. So it's not really hard to find. So you can just double click anywhere and it brings up these page properties, page position right here, and all these other fun little tools. And then I'm going to go ahead and remove those toolbars set for us, because I think it looks nicer without the toolbars, honestly. And then the last but not least, we're going to go over static page, and I'll give you a little cool demo with connection with a PLC if we have time. But here's the static page. We can use a static page for our purposes for the presentation. I just did CIMON logo because it's CIMON, it's us, we're the ones doing the presentation. But for anyone else's purposes, you can put buttons on there. So whenever you're changing to another page, the buttons don't disappear like they were for mine, because when I press a button, I go to a different page and the buttons are somewhere else. Well, on your static header and footer, you can have buttons on there. So whenever a page changes, you can still press a button like log in or log out, stuff like that. Mine's kind of not as good as I would like it. Static page, we can use the static page for navigation, and then it only does it once. So it only once you run it, the static page will stay there. So the way to do that would be go to File, Static Page, and Multi-Monitor. Number of static pages, 1 up here, or number of pages for the static, 1, and then we can choose menu header or the name of the page that we're talking about. So for us, I did footer and header. You'll see the name is named menu footer and then menu header. So I go File, go to Static Page and Multi-Monitor, and then I chose, it doesn't really matter the number of pages that you put up here. It's just saying that I'm going to have 3 static pages, even though I have a blank one. It doesn't really be used. So I have this one static page, menu footer, and then menu header. So you would think that putting menu header below menu footer would change anything, but it really doesn't. It depends on the run position you chose for the page properties. So menu header will be our logo, and then menu footer will be our logo. So when I run this, these bars up here, this top and this bottom, these are the static pages. So whenever I change a page, those never change. And it doesn't matter. Again, PLC. The static page stays all the same. Now, with the time remaining, I'm going to go over our PLC communication, just a little brief overview, and then also I'm going to go over HMI connection, how you would talk to an HMI. So essentially making the SCADA the client, and then turning an HMI, which is normally a client, into a server. So it's going to grab data from the HMI and put it onto the SCADA. So let's go through that real quick. I want to exit, yes. Pull up CIMON. Where'd you go? So it's a little stepping up and down feature, like it's filling a tank and it's refilling a tank. Some physical values here, like M100 and an MC. I'm not going to really get too much into it. I just want to show that it has the functionality to do this. So connect option. I'm going to go to simulator. Press OK for simulator. There we go. Simulator starts. So now we have a simulator up. All these functions are going. It's a fill and drain tank simulator. So now when I go back to SCADA and I look at my simulator IO device that I've already created, I'm choosing the IP address of the computer, because the computer is 127.0.0.1. That would be the simulator IP address. And then we have to choose COM blocks to talk about, so D, M, X, and Y. So these values will only be used if they're listed. So I can't use like a Z or a T unless I declare them down here in the COM block. So the COM port, I chose 000 because that's the IP we're dealing with on the computer, because it's the actual computer itself IP address, but this is the communication between the PLC and the SCADA. And then also on top, or let me just go through the PLC part first. So we have to log in to get to the PLC, right? Because we can't just click that button because of security issues. Log in, PLC. Now, this is going to start filling and draining when I press it. Notice how this wasn't on before? Now if I click it off, it will be off. So on and off based on the script. And then I can reset this if I want. I can choose to manually drain it. It'll start draining on its own. And then this little word down here will show you the operation of the tank, what's going on right now. I mean, this is very simple. Nothing mind-blowing here, but yeah, it's a simple communication with the SCADA to the PLC. You're just going to use PLC Ethernet protocol. So let me back. And one more thing, and then we're done. So then that was communication with the PLC. So just a reminder that the protocol was PLC, the external hybrid of all the PLCs we were talking to. And then for tests, this is talking to the HMI, where the SCADA becomes the client and the HMI is the server. So you're going to choose the station type. You're going to use CIMON X panel Ethernet communication. So from the start, you would go to IO device, new device, CIMON X panel Ethernet. You would choose that. That would be the protocol type. And then once you go to that, you need to declare the COM blocks. So when you're talking to the HMI, there's only D and S. So D can be analog, digital, or it can be, well, digital or analog, including float for the analog part. And then S can be string, so your text. So there's only two needed variables in the first place. You just have to assign them to the D register or the S register within the HMI. So creating a data server, essentially. And then that about wraps it up for today. Thank you for showing up, everyone. And there is a phone number and some email addresses for you if you need some support. And thank you very much for showing up today.